Okay, so this is exam review question number 2. We have a rectangle, has an area of 14 square meters, whose face points in the direction of 3i plus 4j plus 2k. Find the vector area. Find the area of the rectangle when projected into the xy, yz, and xz plane. So we're told we have a vector area. We're told that we have a rectangle, so somewhere in space we have a rectangle. And the vector area is 14 square meters, so I'll just write this as 14. And whose face is pointing in the direction of 3i plus 4j. So there is a vector. It's not a directional vector, but it is a vector. And so I'll just call this a vector v. This vector has a direction that's basically the normal to the rectangle. Its face is pointing in the direction of 3i plus 4j minus 2k. So remember, if you want a directional vector, we have to convert this into a unit vector. So the directional vector, I'm going to donate this, is given by 3i plus 4j minus 2k divided by the magnitude. In this case, it happens to be 3 squared plus 4 squared plus 2 squared, negative 2 squared, 2 squared. So whatever this is the directional vector, and so find the vector area. So we have some coordinate system x. So this is your x-axis, here's a y-axis, and here's your z-axis. We have some rectangular plane. The vector area is just basically times the magnitude of the vector area times the directional vector. That gives you, in this case, it happens to be this. So we have 14 times 3i plus 4j minus 2k. The directional vector is given by 3 squared plus 4 squared plus 2 squared. So this is the vector area. So this is the vector area. So remember, areas are vectors. So I know in high school or grade school you always thought that areas were basically just a scalar value, but they're actually directed oriented. So the next question is, find the area of the rectangle and project it into the xy plane, yz plane, and xz plane. So we have a rectangle. So if I project it into the xy plane, so this rectangle is being projected into the xy plane, which is some kind of a parallelogram. Okay. So this parallelogram, you'll notice that the projection, right, is a component along the k direction. So what we really want is the k component of this vector. That's your projection. So the k component of this vector is sometimes referred to as a dot k vector, the dot product, if you want. It's really the k component, which is really, so there'll be an I component, the j component, the k component. So the k component will be negative 14 times 2 over the magnitude of 3 squared plus 4 squared plus 2 squared. So I know that it looks weird having a negative value for the area of the projected area. What it means, right, is that when the front of this face, when projected onto the ground, happens to be pointing down. So what we're seeing is actually the back end of the rectangle is not pointing up like away from here, it's actually pointing down, and that's why we have a negative value, and so the projection happens to be a negative area. So this is the answer is the projection, and of course the units, right? If my standard units are in meters, this will be meters squared. Okay, so similarly, right, this is for the xy projection. Similarly, if I want to find the yz projection, so the yz planes, I'm taking this rectangle, projecting it into a parallelogram in the yz plane. Notice perpendicular is x, so it's really the x component. So it's really the I component, and the I component in this case, is it on the board? Yeah, it's still on the board, good. I component would be 14 times 3 times the square root of 3 squared plus 4 squared plus 2 squared. and whatever the answer is, this rectangle projects into a parallelogram, and the area of the parallelogram is this number. And don't try to calculate these numbers. That's not the purpose. The purpose is just to make sure that you understand where everything's coming from. So it's meters squared. So the answer is that the rectangle projects into the YZ plane, and perpendicular to the YZ plane is along the x-axis. So, and similarly, we can get the projection of this rectangle into the what's another question, is the XZ plane. We're projecting it onto this plane right over here. And so the area of that parallelogram of the rectangle becomes A vector dot, and remember XZ is this the I core J direction, the J direction, and the K direction. I direction, J direction, K direction. So we're looking at the J component. So the area is really the A dot J, which in this case happens to be 14 times 4 over square root of 3 squared plus 4 squared plus 2 squared. And so the answer is in square meters, but that's what the rectangle. So if we have a rectangle in space, and this rectangle is given by this directional vector, so we have some rectangular in space, it's some space rectangle, and the projection on it and the front face of the rectangle is pointing in this direction. So the area times the normal vector. Then the projection, right, gives you these components. So this is exam review question number 2.